Okay, so I'm gonna get started because it's half an hour on the clock, and I don't want to run into anyone else's time. So thank you for those of you who have joined so far. I appreciate that you've chosen to spend the next half hour with me. My name is Cora Iberkleid. I am a part-time advisory solutions engineer, part-time developer advocate at VMware. And the topic that I'm going to be talking about today are admission controllers on Kubernetes. And we're going to go over an overview and then focus on a demo of a validating admission webhook. But I'm also going to show you some minimal changes to make to that demo in order to make it a mutating admission controller. So we'll see both. So broadly speaking, admission controllers are plugins that you enable on your Kubernetes cluster, and they act as gatekeepers. So their purpose is really to help you govern or secure the workloads that are going to get deployed into your cluster. They operate on requests after the API, the Kubernetes API server has authenticated and authorized the request, and they can either just accept the request or reject it, or they can change it. So one way to think about these admission controllers is to compare them to like the security scan at an airport, right? So when you're going to take a flight, you arrive at the airport, and in order to get in line for security, usually as you're joining the line, somebody makes sure that you have a plane ticket, and then when you get to the front of the line, somebody checks your ID. So we can say that that's the authentication and authorization that the API server would do. And then you move on to the actual scan, where you and your bags have to be checked to ensure that you're not bringing with you anything that might be unsafe in the terminal or on the airplane. And so that scan is kind of like these admission controllers. And they can, as I say, just accept or reject you, or they may change something about you, right? So like if you're carrying a water bottle, you might be forced to give up the water bottle. So they can also make changes. Now, there's over 30 admission controllers that are included with Kubernetes. They're compiled right into the Kubernetes API server, and they are enabled or configured by the cluster administrator. So a few examples of these are one, for example, called the namespace lifecycle. And this controller basically prevents any objects from being created in a namespace that's in the process of being deleted, right? When you delete a namespace, it doesn't get deleted instantaneously. It enters a state called terminating. So as long as a namespace is in that terminating state, this lifecycle controller will make sure that you can't create anything in it. Other examples require some configuration. So Limit Ranger can help you either assign default resource requests and limits to new pods, or maybe just check that they're not requesting anything greater than what's allowed for a namespace. Pod security policy is another example. You can disallow containers from running as root. You can ensure that the file system is not mounted as read-write. And then there's two special cases, two special examples that are more dynamic in nature. These are the mutating and the validating admission webhooks. And basically these controllers don't include their own policy logic, but rather they will call a URL to a different application, and that application implements the policy logic. So you provide that external application, and you register the URL to your application as a webhook with one of these two controllers. And the difference, of course, as implied by the name, is that one of them has the ability to change the request that's coming in, and the other one simply says yes or no. It's allowed. So from a flow perspective, this is the workflow. So an API request is made to the Kubernetes API handler, right? Create pod, create deployment, delete something, etc. And the API server authenticates and authorizes that. And then that request is forwarded to all mutating admission controllers. You can have more than one, and they all act sort of in parallel. And each of these mutating admission controllers sends back the change that needs to be made on the request. So after all of those changes are applied, then you have the final version of the object. And so that goes through a validation, and then it's handed to one or more validating admission controllers. And if any single validating controller responds no, then it's rejected. If they all respond true, then the object is persisted into etcd, where after that it's business as usual with Kubernetes. So if you persist like a pod, then after it's in etcd, Kubernetes will go ahead and actually create that pod. Now, with these two dynamic examples, the difference is that you provide that implementation separately from the API server, and then you register that your URL as either a mutating or validating admission controller. And you send back either the patches that you want to make or your validation decision. So the steps that we would have to follow in order to use these controllers are, number one, you have to enable the plugins on the Kubernetes API server. You can enable one, or you can enable both of them. You can enable, of course, any of the other 30 plus. Then you implement your policy logic and make that available. In this case, we're showing an example of deploying your pod with the policy logic and also the service to make it accessible. And then you register your webhook, so the URL to access that service, with the Kubernetes API server. And then you can test it out and use it in your cluster. So I'm going to go into detail on two of those steps, which is, if you're going to implement your policy logic, if you're going to write an application, right, that implements whatever policy logic you want to enforce, the first question is, what is the structure of the request that you're going to receive, and what is the structure of the response you have to send back to the API server? So you can see here that the API server uses the same top-level object called admission review for both the request that it's sending to you and the response that you have to send back. And it then, within that, it uses either a request node or a response node. And then within those, there's another structure, admission request or admission response. So you have to write your code so as to receive this admission request inside of the admission review object, look at the request that went to the API server, decide what to do, and then populate this structure on the right-hand side with the response node and an admission response structure. And I'll show you where to get a little bit more information about what those structures actually look like. The link's also at the bottom, but I'm going to show you that in a minute. So if it's a mutating webhook, then you send back a JSON patch or a list of JSON patches that will be applied to modify that request. And if it's a validating controller or webhook, then you simply send back the true or false to say whether or not you've accepted the request. There's a few other optional fields you can add. The next step is to register your application with the API server, right? So that the API server knows when and where to make that call. So here's an example of a validating webhook configuration. You can also, under kind, you can see that it's validating. You could also change that to mutating, depending on what your application does. And in the middle of the YAML, you can see a rules section. So you can see that you can decide when your webhook is called. So for example, this is only when pods are created, and this is for namespaced objects. Under that, you have the client configuration, which basically gives the API server the coordinates of where your application is. So in this case, we're going to ask the API server to call a webhook server service in the webhook demo namespace. And the path that we've implemented for the request in our code, it happens to be /validate. That can be anything that you want. There's a few additional fields. You can see kind of in the top quarter of the page. Failure policy means like if your pod, for whatever reason, isn't there, maybe just the registration is there or it crashes or something's wrong with the actual deployment, whether or not you allow the request. Side effects says whether by executing your policy logic, if you're having any other effects on the cluster. When you include the side effects parameter in your registration, you're also enabling the ability to use the dry run. So it's good for testing. I'm going to show you that as well in the demo. And the last thing here is the CA bundle at the bottom. So the API server is going to make an HTTPS post request to port 443, right? That's not configurable. So you have to be supporting, you have to configure something that supports the receiving that kind of call. So you want your service at the minimum to listen on port 443. You want to provide your certificate and private key to your pod and put the CA bundle pen-encoded value to validate so that the API server can validate those certs on the pod, include that in your registration. And you can do this if, you can use a cert manager, et cetera, but basically you have to make that information available. So let's go to the demo. And so basically those 4 steps that I showed you in the slide, I'm kind of going to go through those. So the first step was to enable the plugins on the cluster. Now, I have a cluster running locally on my machine. I'm using Kind, which is Kubernetes in Docker. But I'm going to show you here the configuration that I used for the webhook. So you can see in the middle of that configuration, API server, enable admissions plugins. And in that list, kind of towards the end, you can see both the mutating admission webhook as well as the validating admission webhook. So we have those enabled on the cluster. Now, the second step is to implement your code with your policy logic. So I'm going to actually use a demo. This is a demo created by Eric Shanks. He is also the creator of this blog called the IT Hollow. So I'm going to walk through that code with you. And it's just a really good example of, as you can see, it's sort of a basic validating admission controller example. He happens to write it in Python. It's also very common to use Go. Go is a good choice also because the API structures themselves are in Go, and you can use that those objects in Python. In this example, we're just going to use sort of our knowledge of the JSON structure of these of the request and the response. But essentially, this example is going to look for a label called billing in any pods or deployments that are being created. And if the pod or deployment doesn't have the billing label, it's going to reject it. So if we look at the source code for this example, you can see that it's a little web application written in Python. So Flask is a framework for writing web apps in Python. And it defines this route /validate. Again, this is arbitrary. It can be anything you want, but we're declaring it as /validate. You have to support post, as we said, right? The HTTPS post that call that the API server is going to make. And then this particular example separates the code in two functions. So this first function is going to apply the policy logic. So it's basically going to say, if the request contains a label in the metadata section, if it contains a label called billing, then we accept it. We'll return true. Otherwise, if there's no labels at all, if the metadata section doesn't even have labels in it, then we'll return this error here, no labels exist. And if the metadata section does have a label, but it doesn't have a billing label, then we also are going to reject it with a slightly different error message. Now, to send back this response, you can see that it's using a second function, K8's response, for all three of these cases with a different Boolean value. So that function is defined right down here. And you can see that it's basically declaring, just sort of handwriting the JSON structure, where the top level object is this admissions review that we saw in the slide. And then it populates the response node. And then it says, because it's validating, we need to say whether or not we're going to allow the request. We need to pass back the unique ID of the request, which is basically something that the API server added to the request. And here, so we get it from the request, and we just put it right back in the response. And we can also add some extra metadata to say why we're rejecting it. You know, if it's false, it's good practice to put in the reason for the rejection. So if you were writing this, you might want to know, well, how do I know that it's request object before I get to, you know, the metadata of my actual pod or deployment? Or how do I know that this field is called UID and not ID or UUID? Or, you know, how do I know the structure for this response? So that information, first of all, it's in the documentation, but also it's in this GitHub repo called Kubernetes API. You can click on admission, v1, and go to the types.go. And the structure is here. So you have the top level structure of the admission review. So you can see it either will have the request or the response nodes. Here's the actual lowercase name of it. And the request will contain an admission request structure, which is defined here. So you can see, in fact, the UID is something we need to get out of it. And also the object here is the original incoming request. So once we're inside of the original object, then the structure of that will be, you know, if it's a pod, it'll be a pod structure. If it's a deployment, it'll be a deployment structure. And for the response that we're creating, here's a structure. So that UID field, again, is top level. There's a Boolean of being allowed or not allowed. And we can also add this status. You can look up this other status structure separately and see that it has a message. Now that's for a validation. If we were doing a mutation, then we would also want to send back the patch, the JSON patch that should be applied to the request in order to make the change that we want to make. And the patch type right now is only allowed JSON patch. So that you would need to add that. So the last thing I want to show you in the source code actually is this providing the SSL context for that HTTPS request. Again, you can do this in a few different ways, but in this case, we're going to actually put these inside of the image when we build the image. So we just have to make sure that in our local directory, we have these files to copy into the image. So I'm going to show you the creation of these, the search directory, and then these two files so that we can build it right into the image. So going back to the demo, let's go ahead and clone that repo and cd into it. So you see that this repo happens to include this certificate generation script. So that's pretty handy. So we're going to create a search directory and then run that script. And so now we've got the files that we need. We actually only need to copy these two files into the container. And you can also see that this common name matches. This is going to be the name of our service in Kubernetes. This is going to be the name of the namespace in which we're deploying it, and it's a service. So this matches what we're going to deploy. Now, so now we've got all of the files that we need to package into our image so we can build it. So here's our Docker file. You can see that it starts with a basic Ubuntu message. Then it installs the OS packages that it needs for Python. It copies the requirements file. So the requirements file is the file that lists the specific Python dependencies that our source code uses, like Flask, for example. And it does a pip install for those files. And then after that, it copies the rest of the files. So here's where we'd be copying the two search files as well as our warden.python source code. And then it declares what the startup command should be when this is run as a container. And this is common practice in Dockerfile to do OS packages first, application dependencies after that, and finally source code, because source code is more likely to change than dependencies or OS packages. And by ordering things and separating them in this way, you can have more efficient subsequent builds because you can reuse the layers created by these earlier instructions. The only thing I would suggest on top of what's in this demo is to add a .docker ignore file, because here, this instruction here is actually copying everything in the local directory into the application. And we know that we actually only need to be able to copy this requirements file as well as our application code and the certificate PEM files. So by using a Docker ignore file, which is kind of like a git ignore, it filters what we're going to upload to the Docker daemon for building the image. We can make sure we're only copying what we need. So that's the only, it's not necessary, but it's kind of good practice. So now we can build the image, the image that we want to create. As you can see, I'm running a registry on my local Docker daemon. So it's just a little faster to do it that way than to use Docker Hub. So here we go. We've generated our image, and now I can push it up to my local registry, right? It creates it on my local Docker daemon, and now I'm pushing it up to my registry so that when I deploy when I apply my YAML file, my cluster will be able to find it at this address. So we'll just give that a quick second to finish uploading. Okay, great. So now we can deploy this. So let's review the deployment file. So we're going to create a new namespace called validation. And in that namespace, we're going to deploy our image that we just built. Now, of course, I have to update this, the IT Hollow from the example in the repo. I'm going to update it to be localhost 5000, matching what I just created. But otherwise, the only other thing here to notice is that we're going to create a corresponding service for this. And this matches, of course, what the common name I showed you was warden validation, and it's configured to receive traffic on port 443, right? Exactly as we're expecting from the Kubernetes API server. Of course, then it can redirect to any port on your pod, but you at minimum have to be receiving this traffic on this port in your service. So we can, first of all, just quickly change that registry address from the IT Holo to localhost 5000. And now we're ready to deploy this to our cluster. So there we go, create the validation namespace, create the pod, and create the service. So, okay, so we've got this pod and service running in our cluster, but it doesn't mean that this pod is going to be called when we do any kind of deployment. We first have to register it, right? That was the next step. Tell the API server that we want this pod to be enforcing policy. So for that, that's also a YAML file. So in this case, we're using the validating webhook configuration. This is our registration, and we've got our rules. So we're saying we only want our pod to be, this webhook to be triggered if somebody tries to create a pod or a deployment. This is where, how to find our service pointing to our pod, warden, validation namespace, and this is the path. And we're declaring that there are no side effects. And by doing that, we're also enabling ourselves to use that dry run, as I mentioned. And if our pod is not available, we want validation to fail, right? So the last thing we need to do is provide this value. As we said, this should have a PEM encoded value so that the API server can verify the certs on the pod. And so we're going to pull that out of our CA cert file and just copy that value. And I'm going to basically just paste it in at the end of the file here. Okay, so now that we've updated our registration file, we can go ahead and apply that. And okay, so at this point, we've registered our webhook with the API server. So the next pod or deployment that is created on the cluster should trigger our policy. So let's test it out. So first of all, let's just make sure that our warden pod is actually up and running. It's ready, good. So this demo repo handily contains 3 different test cases for us to verify. So the first test case is one that has metadata labels billing. So we would expect this one to succeed. So if I run this one, I'm going to run it with a dry run option first. You want this to run on the server side, of course, right? So this tells us that this pod would succeed. It would be created, but it's telling us also it's a dry run. So that means that the pod was actually not persisted in etcd, and in fact, we can validate that there's no pods in the default namespace. If I run that same command again without the dry run, then I also, of course, get the successful response, and I see that the pod has been created on the cluster. Now, the other 2 test cases are this one, which shows that the metadata only has a name. There's no labels at all, and so we would expect this one to fail with one of the 2 error messages. And in fact, here it is, no labels exist. And the next test case was there is a label, but it's not a billing label. So we would also expect this one to fail, just with a slightly different error message. And so here we get not allowed without a billing label. So that's basically how these work. Now I'm going to go ahead and delete our validating webhook configuration. So deregister, and I'm also going to go ahead and delete the pod that we had deployed. And lastly, I'm going to delete the single of these 3 pods that we tried to deploy. Only pod test 1 was created, so I'm also going to go ahead and delete that test pod. So in the last few minutes that I have left, I wanted to show you what are some minimum changes that you could make to this example if you wanted to test a mutating validation webhook. So I'm going to copy over a slight variation of that source code and just show you the differences. So I'm going to use also an updated requirements file. Okay, so the only differences between the old source code and the new source code, because I did this with minimal changes. So I'm importing some extra modules here for the JSON patch handling. And I basically only added these lines of code, over here. So I'm basically saying that when I generate the response, so it's going to be the same policy logic, right? So it's going to say, if you do have a label called building, we're going to accept it, and otherwise we're going to reject it. So you can even see that the mutating webhook can act as a validator, which is not true the other way around, right? The validation webhook cannot act as a mutator. The validation is only allowed to respond yes or no, but the mutator could do both. And this is useful because maybe as a cluster administrator, you might think it's risky to have the mutating controllers enabled. You just don't want that as a policy, so you can just disable that and still use a validation webhook. But if you do want to be able to do mutations on requests that are coming in, then this actually can function as both. Just remember that it's better to use a validation webhook for actual validations because they operate on the final version of the request, right? The mutators are going to be operating on the version that they're getting rather than a version that's after all other patches have been made. So really you do want to use each one for what its purpose is. But so in any case, if we do find that the incoming request has that billing label, then we want to modify it. And we're going to do, this is our patch. First we create a patch. And so we're saying that we're going to do an add operation to add another label. So / metadata labels, add a demo label with a value of code connect. And then we base64 encode that. And in the response, we just simply add these last two fields in addition to what we were sending by in the original code. So we're saying that the patch type is JSON patch, and then we're sending this the value of this variable as the actual patch. So that's really the difference there in the code. So we can go ahead and rebuild that container or rebuild that image. So here it's downloading those extra packages from Python and rebuilding it. We have to, of course, push that up to our local host registry again. And then the only other change we have to make is that after when we want to register this, that instead of registering it as a validating webhook controller, we register it as a mutating one. But that's really it. And then we can apply that registration. So now we've got a mutating webhook configuration, and we can go ahead and retest that. If we apply all the pods, so we would expect, again, the first one to succeed and the second and the third ones to fail with the same error message as before. That's the first expectation. And then for the one that succeeded, we're expecting to see that we've added this label called demo code connect. So we've actually changed the incoming request. So that's all I have for demo. The only other thing I guess I wanted to show you is just some resources that I hope are useful, which are these links over here. So this is the documentation in general on admission controllers. The API structures that I showed you, they're also, of course, in the docs, but you have in the Kubernetes API Git repo, you've got the admission types and some others, and then the generic metadata like the status are in this Kubernetes API machinery repo. This is the demo that I used for this talk. This is the original blog posting, and this is the GitHub repo. And then actually this is, Paul Zarkowski has a fork of this same repo. If you check out the TGIK branch on that, then you'll see just a slight variation on the same demo using a cert manager for the certificates. So that's all I have for you. And again, I really appreciate your time. Feel free to reach out to me at Iberkleid on Twitter, and enjoy the rest of the conference.
Thanks a lot. That was awesome. There's sessions the rest of the day. Thanks, Cora. And if anybody has any questions, I can hit them up. I don't see any questions right now, but thanks a lot for being here. And sessions all day long, hackathon at 5 tonight, awards, as well as awards for the scripting contest. So hope you can join us for the rest of the day, 3 different tracks, lots of sessions to check out. Thank you very much.
Thank you.